Section 5.2 continued, verifying trig identities. Please refer back to the section in Part 1 that has helpful hints for verifying identities. Here what I want to do is begin with the most difficult side first, and I'm going to work with one side. So what I'm going to do is simplify this left side by foiling. That's going to give me tangent squared x times cosine squared x. Now my outer terms, tangent squared x times a -1 minus tangent squared x. My inner term is plus cosine squared x. And my last term is -1. Since tangent squared x is multiplying cosine squared x, I can use one of my identities to change tangent squared x into sine squared x over cosine squared x times cosine squared x minus tangent squared x plus cosine squared x minus 1. The cosine squares will cancel out. That leaves me sine squared x. And I'm going to move the cosine squared x adjacent to it. Minus tangent squared x minus 1. I know that sine squared x plus cosine squared x is a Pythagorean identity. Sine squared x plus cosine squared x is 1. So I will substitute that in. Then I can simplify 1 minus 1 cancels. That gives me a negative tan squared x equals a negative tan squared x. Therefore, I just verified that the left side of the equation does equal the right side. Again, I want to verify the trig equation. And what I'm going to do is work on one side of the equation. I'm going to work on this side. It looks more difficult to me. So what I'm going to do is convert 1 over secant x into its reciprocal function, which would be cosine x. And 1 over tangent x is cotangent x. Now I'm going to convert cotangent x into cosine x over sine x. That gives me cosine squared x over sine x. I know I can have an alternative form of the Pythagorean identity to be sine squared x plus cosine squared equals 1, but cosine squared x is equal to 1 minus sine squared x over sine x. Then I can break this up into its two terms over the common denominator of sine x. That would give me 1 over sine x minus sine squared x over sine x. Using the reciprocal identity, 1 over sine x is cosecant x minus, simplifying, gives me just sine x in the numerator. And that gives me what I'm looking for, which is cosecant x minus sine x. Again, I'm going to work on one side of the equation, and this one looks more difficult to me. I'm going to put the common denominator over each term in the numerator. That's going to give me tangent x over tangent x cotangent y plus cotangent y over tangent x cotangent y. And I want to simplify each. Tangent x cancel. That gives me 1 over cotangent y. Plus, here my cotangents y cancel. I get 1 over tangent x. And using the reciprocal identity, 1 over cotangent y is tangent y. Plus 1 over tangent x is cotangent x. And that gets me exactly what I'm looking for on the right side of my equation. In this last example, I want to work on both sides of the equation. Recall, if I have an expression on the denominator, I can multiply the numerator by secant alpha x plus tangent alpha x. So let's take a look at that situation. Secant alpha plus tangent alpha over secant alpha minus tangent alpha times secant alpha plus tangent alpha over secant alpha plus tangent alpha. On the right side of the equation, I'm going to factor the numerator. And that's going to be 1 and 1 and sine alpha and sine alpha. And when I FOIL, 1 times 1 is 1. Outer sine alpha, combined like terms would give me 2 sine alpha, and sine alpha times sine alpha is sine squared alpha. And this will be plus, plus. On the left side, since the numerators are the same, I can rewrite that as secant alpha plus tangent alpha quantity squared. On the bottom, I can FOIL. Secant times secant is secant squared alpha. The middle term minus tangent secant. Outer term, positive tangent secant would drop, minus tangent squared alpha. On the right side, since these two quantities are the same, I can rewrite those as 1 plus sine alpha, quantity squared, over cosine squared alpha. On the numerator, I can rewrite this as 1 over cosine alpha plus sine alpha over cosine alpha. And remember that that quantity is squared. Then I have a Pythagorean identity for the denominator. I know that secant squared alpha is actually tangent squared alpha plus 1. And I just bring down the right side. On the left side, in the numerator, I have common denominators. So I can just rewrite that as 1 plus sine alpha, and that quantity is squared, over cosine squared alpha. And on my denominator, tangent squared alpha minus tangent squared alpha, they cancel, and I'm left with 1, which leaves me what I've just written. And that matches my right side.